Welcome to waidusmacademy. Today we'll be looking at carbon and carbon cycle. Okay, before we begin to explain the carbon and the carbon cycle, what happens, how carbon dioxide is in form of what in the air. It's not just in form of carbon in the air, it's in form of carbon dioxide. Just like nitrogen is not just in form of nitrogen in the soil, it's in form of nitrate in the soil. So carbon is in form of carbon dioxide in the air. So we're going to talk about this, but before we talk about that, let's first of all take a look at the element called carbon. Now, carbon is found in the earth crust, right, as a free element. It's found on the earth crust just as a free element in two forms. It's found in two forms, meaning it has two allotropes. Okay, it has two allotropes. One, we have what we call the diamond. Carbon is in the form of diamond, and is also in the form of diamond, and is also in the form of graphite. So carbon is found as an element in free form on the earth crust in two forms. One is as diamond. Carbon exists as diamond, and another one it exists as a graphite. It also exists as graphite. So we have two allotropes or two forms of carbon. So carbon is in form of diamond. It could be diamond or it could be graphite. So these are the two forms or two allotropes of carbon, or two states upon which we can find carbon existing on the earth crust. So we call these two forms allotropes. Diamond, as we know, is the hardest substance on earth, right? Diamond is a very hard substance, while graphite is one of the softest, right? We can say one of the hardest, okay? Like one of the hardest substance on earth, diamond. So, which means carbon has varied characteristics. Varied characteristics. It exists as diamond. Carbon exists in form of diamond, which is the hardest substance on earth, even harder than metals. And it also exists as graphite, which is one of the softest substance on earth. So you can see the nature of carbon. It exists in the form of diamond. It exists in so this we call allotropes. We can say the two allotropes. The two allotropes of carbon is that carbon can exist in the form of diamond. Allotropes of carbon can exist in form of diamond, and it can exist in form of graphite. This is one of the softest. The graphite is one of the softest, while the diamond is one of the hardest substance. Okay, so you can see carbon is funny. It exists in diamond and it's the hardest you can imagine, and it exists in graphite as one of the softest you can imagine. Now let's take a look at this. Is in form of element, okay? Like carbon exists as free element. So we're talking in terms of element here. Now let's look at carbon in form of compounds. You know, elements react together to form compounds, right? So let's look at carbon in form of compounds. Let's look at carbon in form of compound. This is in form of element. So when we look at it in form of compound, we have a new story, right? In form of compound, carbon reacts with what? Oxygen to form carbon dioxide, carbon monoxide, and so on and so forth. So there are so many reactions that goes to form compound, because compound is the combination of two or more elements chemically combined together. When two or more elements chemically combine together, then we have a compound, right? When they physically two things or more things are physically combined together, we call them mixture. Remember this. You studied this before. So two things physically joined together become mixture. But when they chemically join together, we call it a compound. We call it a compound. When they chemically combine together, we call it compound. Now let's take a look at carbon compounds. There are thousands of carbon compounds in nature. There are thousands, because carbon can react with so many things. Can react with so many things. Can react with oxygen. Can react with so many things. Okay, it reacts with hydrogen to form methane. Reacts with oxygen to form carbon dioxide. So it can undergo series of reactions. There are thousands of compounds of carbon. In living things alone, you know, in the soil, in the ocean, you find them. In the soil, you find them. In the atmosphere, you can find carbon in form of carbon dioxide. In the atmosphere, carbon is in the form of carbon dioxide. So in the atmosphere you find, in the soil you have carbon compounds. In the ocean you have carbon compounds. And so on and so on. In different places you have carbon compounds. So carbon compounds exist in various phases of life. In the atmosphere you have it as carbon dioxide and so on and so forth. So it's well around us. You are around about 75% water by mass, right? The world is about 75% of water, right? And around 20% of it is carbon. Around 20% of it is carbon. So it's a lot. Now let's take a look at the carbon cycles. Now we've talked about a bit of elementary of carbon. The cycle it undergoes, the carbon cycle. Now, when we talk about carbon cycle, we will be referring to how we get carbon from the air to the soil back to the air, like the whole phenomenon, what's happening. So what is happening to carbon, how it's being released to the air, and how we get it from the air, and what processes and what organisms uses the carbon. So this is what we mean by carbon cycle. Now, first and foremost, we see here carbon in the air, right? Or carbon dioxide. Actually, carbon dioxide in the air, not carbon in the air. Carbon by itself is not in the air. Carbon by itself is not just in the air. We say carbon dioxide, CO2. So permit me to write CO2 here. Carbon dioxide is what is in the air. Okay? CO2, carbon dioxide. So carbon dioxide in the air, right? Carbon dioxide in the air. Now, this carbon dioxide that is in the air, how is it taken away from the air? How does it leave the air? What process takes away carbon from the air? One of the processes is dissolving it in the ocean, like this place. Say we dissolve it in the ocean. Carbon dioxide get dissolved in the ocean and then goes to the ocean. You know, because it's in the air around the ocean also can mix. The ocean and the air can mix together. Because when we say it's in the air, it's not only on the top atmosphere, just above the water, above the ocean. Carbon dioxide. So this carbon dioxide that is blowing on top of the ocean can get mixed with the ocean. And when it gets mixed with the ocean, it gets dissolved in the ocean. So the carbon dioxide gets dissolved. When it happens, this dissolved carbon dioxide releases carbon to carbon compounds in fossil fuel. When it gets dissolved, you know, fossil fuel is from the ocean, the petroleum. You know, we drink from both the onshore and offshore. But most of the time, at the bottom of the ocean, we have fossil fuel. So when this carbon dioxide dissolves in the ocean, it goes and forms carbon compounds in fossil fuel. It forms carbon compounds in fossil fuel. That's the coal, the petroleum, and natural gas that you have under the water, under the ocean, or under the sea. So the carbon dioxide in the air dissolved in water to join the other organic substances that form the fossil fuel. That's the first point we know. So one of the way carbon dioxide is taken away from the air is dissolving it in the ocean. The carbon dioxide gets dissolved in the ocean, and the dissolved carbon dioxide is used in forming coal, petroleum, and natural gas. Then another very unique way of removing carbon dioxide from the air is by photosynthesis. Another way, the second way, because we have two great ways of removing carbon dioxide from the air. The two very strong way of removing carbon dioxide from the air. Number one is dissolving it in the ocean, the way I've just explained. That the carbon dioxide in the air can be dissolved in the ocean, and the dissolved carbon dioxide is used in forming carbon compounds in fossil fuel. It's used in forming carbon compounds in fossil fuel underneath the soil, underneath the ocean. That's number one. Number two way of removing this carbon dioxide from the air is actually by photosynthesis. You remember photosynthesis, what you studied in the photosynthesis, we say the leaf of the plant that have the green pigment, the chlorophyll in the chloroplast of the plant's leaf, trap the sunlight energy, right? It traps the sunlight energy. That's one. Then we say the carbon dioxide in the air diffuses into the leaf through the stomata, diffuses into the leaf. So during for photosynthesis to take place, For photosynthesis, the water is taken from the root, by the root hair cells. The water is taken from the soil by the root hair cell, and it's transported through a xylem vessel to the leaf. So the water and the carbon dioxide is coming from the air. So the carbon dioxide that enters the leaf from the air is used to photosynthesize. Is used to make food. Is used by the plant to make food. Now the plant on the land and also phytoplankton in the sea. So photosynthesis by green plants on the land and by phytoplankton in the sea. So both the plants on the land and the plants in the water, the plants in waters are called phytoplanktons. So photosynthesis takes away carbon dioxide in the air, helps to remove carbon dioxide in the air so that the green plants can manufacture their own food. So the two ways we've mentioned that this carbon dioxide in the air is taken away from the air is by dissolving in the ocean and by photosynthesis. Photosynthesis by the green plants in the land and by phytoplankton in the sea. The phytoplankton in the sea. When that happens, when this one happens, then carbon compounds will be found in the plant. Carbon compounds will be found in the plant. You know why? Because the food you make, for example, let's say glucose, is C6H12. The glucose that is made, you see there's carbon, it's a carbon compound, H12O6. So you can see the glucose that is manufactured is a carbon compound. Even the protein that is manufactured is also a carbon compound, it contains carbon. So you can see the food that you manufacture during photosynthesis is actually a carbon compound that is found in plant. Okay? It's carbon compound that is found in plant. Now these plants will be eaten by animals. You know, the animal feed on the plants. They eat the plant. So they are taking the carbon compounds into themselves. The animal take carbon compounds by feeding process. By a process known as feeding mechanism. Okay? The animals, they get the carbon compounds by eating plants. Whether in form of crops or green vegetable or seeds or fruits, whatever. As long as you eat plants, you get the carbon compounds into your body. The animal gets into their body. Now this animal, when they die, you know, animal will eventually die. They will eventually die, right? Plants, when the plants die, because we have to talk about this. When the plants die, they add carbon compounds to the soil or to the ocean as to form the phytoplankton. The phytoplankton, when they die in the sea or in the ocean, they form fossil fuel. Okay, when they die, when the plants die, they help in forming fossil fuel. When the animal dies and they decay, then the bacteria will feed on them. So feeding the dead plants and animal, this bacteria will feed on the plants, will feed on the animal. So they get carbon compounds. Now, how does this carbon dioxide return to the air? One, you know, the plant, they respire. So when they respire, they release carbon dioxide during respiration to the air. The animals, when they respire, they release carbon. When we breathe out, okay, we release carbon dioxide to the air. 3 ways. You see, this is the first arrow. By plants. Respiration by plants, they release carbon dioxide to the air. The second one is this one. When the animal respire, when they breathe, they release carbon dioxide to the air. Similarly, the bacteria, when they respire, when they breathe, they release carbon dioxide to the air. So these 3 categories, they return carbon dioxide to the air by respiration. By what? By respiration. Both the plants, the animal, and the bacteria, when they breathe, they return carbon dioxide to the air. Is that okay? So we've talked how it's being removed. We've also talked about how it's being returned. But that's not all on the returning of carbon dioxide to the air. Another way is, we say the carbon compound in fossil fuel, you know, we extract them, we drill petroleum, we refine them, we burn them, we use them in the car, in the aeroplane, in the diesel, in diesel engine, so many things in cooking, as kerosene, for cooking, for aviation fuel, for gas, for whatever you as long as you're burning them. So when you burn them, you release the carbon dioxide to the air. You release the carbon dioxide. So the fossil fuel, when you burn fossil fuel, you release carbon dioxide to the air. Now, how will return carbon dioxide to the air? We've talked about, first of all, the organic materials, like the plants, the animal, and the bacteria. All three of them return carbon dioxide to the air by respiration. You take note of that. So the plants, the animal, and the bacteria, when they breathe, they return carbon dioxide to the air. Then the fossil fuel, when we burn the fossil fuel, we return carbon dioxide to the air. Right? And we say the carbon dioxide in the ocean, we also say is part of when it dissolves in the ocean, when the carbon dioxide dissolves in the ocean, it's formed part of the coal, the petroleum, and the natural gas. And then when you burn that, you return carbon dioxide to the air. So we practically talk about this. We can consider it as one entity by respiration and by burning. So two ways of returning carbon dioxide to the air is by respiration and by burning fossil fuel. Two ways of taking it away from the air, taking carbon dioxide from the air, is by photosynthesis and by dissolving carbon dioxide in the ocean. So two ways of taking away carbon dioxide from the air. This is what we call carbon cycle. We take it away, we return it back. We take it away, we return it back. It's a cycle. That's why we call it carbon and carbon cycle. We take carbon dioxide away from the air, or carbon away from the air, we return it back to the air. We take it away, we return it. We take it. Now, the rate at which we are returning it back to the air is getting too much. That's why we have greenhouse gases, global warming, which we're going to talk about in one of our sections. The rate at which we're returning it back to the air is more than the rate at which we're taking it away from the air. So as such, carbon dioxide is getting too much in the air, and it's causing global warming, it's causing greenhouse gas and all of these other effects. Why? Because we're burning too much of fossil fuel, coal, petroleum, and natural gas. We're burning too much of it, and also, especially this aspect. Because of this, we're returning too much carbon dioxide in the air. We're polluting the entire air, and that's causing climate change. We're going to talk about that in another section. So it's causing a lot of climate change, which we're going to talk about. But although we also said the plant respiration, animal respiration, all of this will talk carbon dioxide in the air, bacterial respiration, all of this will talk carbon dioxide. This is moderate. But this is a lot also, because there are about 8 billion human beings alone that are breathing and returning carbon dioxide to the air. Then there's so many billions of animals and different species of billions of animals that are breathing and returning carbon dioxide to the air. So you can see the rate at which carbon dioxide is being sent to the air is way higher than the rate at which it's taken away from the air. Okay, because we're not even planting a lot of trees. We are even causing deforestation. We're killing a lot of things, deforestation. We're doing the desert encroachment. We're spreading desert everywhere in the world by our own human activity. So we are not planting a lot of trees or a lot of plants that will help to take away the carbon dioxide in the air. So we are even killing trees for timber, for making furniture, paper, and all of this, for books and all of this. We're falling down trees. We're destroying the forest and so on and so forth. So this ordinarily was supposed to help us to take away the carbon dioxide away from the air, to reduce the pollution in the air, and hence improve our environment and reduce climate change. But we're not doing that. We're not planting a lot of trees. We are even killing trees and deforesting everywhere, and using it for our furnitures. We even using trees to build houses in many of the countries, and so on and so forth. For roofing houses, we use trees. So we use trees to make even the paper, the books we are using to read and to write, and all of this we're using trees. So we're cutting down trees a lot, and we're not planting as much as we are bringing them down. So there's not much effort of taking out the carbon dioxide from the air. And more so, the one that gets dissolved in the ocean is just the carbon dioxide around the ocean environment. The carbon dioxide that is not around the ocean environment does not get dissolved in the ocean. Okay, the one around the ocean environment, not even the whole percentage of it, just a small fraction or small percentage or small ratio of it get dissolved in the ocean. So the rate at which we are taking away carbon dioxide from the air is way lesser than the rate at which we are returning into the air. Respiration alone is bringing a lot of carbon dioxide back to the air. Respiration by these three segments, by plants, by animals, and by bacteria, is returning a lot of carbon dioxide to the air. And burning fuel, burning coal, If you go to industrial area, they use coal. You go to UK, you go to China, they burn a lot of coal. Coal returns a lot of carbon dioxide to the air. Petroleum, drilling, extraction, refining, all of this burning, usage of the refined product, using petrol in your car. As you drive on the road, you're returning carbon dioxide to the air. So as you cook in your house, you're returning carbon dioxide to the air. So we are doing so much, we're returning so much carbon dioxide in the air that it's way greater than what we are doing to remove, to clean up. Okay, so this is what we call the carbon cycle, and this is what we need to take note regarding the carbon cycle. So in case in the exam you're being asked to draw the carbon cycle, you should know there are two ways to take it away from the air, and there are two ways to return it to the air. But the two ways to return it to the air has three components: plants, animal, and bacteria returns it by respiration, and burning fossil fuel return carbon dioxide to the air. Two ways to take it away from the air is by photosynthesis. The photosynthesis in this regard is not only the plants on the land, the phytoplanktons in the sea also photosynthesize and take away carbon dioxide from the air. Another way to take it away from the air is by dissolving carbon dioxide in the ocean, by a process whereby carbon dioxide gets dissolved in the ocean, and this dissolved carbon dioxide is used in forming fossil fuel. So this is what it is when we talk about carbon and carbon cycle. Okay, now let's take a look at some few notes. Like we said, I think we've explained the concept: respiration, combustion. Respiration, we say respiration takes a return carbon dioxide to the air. Combustion, because this burning means combustion. Okay, when you say burning produces carbon dioxide, so we say combustion. Okay, respiration and combustion, they are the two processes of returning carbon dioxide to the air. So in the exam, they ask you to name or explain or describe the two processes by which carbon dioxide is returned to the air. Number one is by respiration. Number two is by combustion. Okay, in the exam paper, they ask you to explain the two processes in the carbon cycle by which carbon dioxide is returned to the air. Number one is by respiration. Respiration of what? Respiration of plants, respiration of animals, and respiration of bacteria. All these three organisms we respire: plants, animals, and bacteria. All these three organisms we respire to bring carbon dioxide to the air: plants, animal, and bacteria. So we need to understand this. I've already explained this concept, and these are the questions that can come in the exam to explain the process by which carbon dioxide is returned to the air. Okay, so this is considered one phase, respiration. Consider one phase by which carbon dioxide is returned to the air. Another method is by combustion. Combustion means burning. Combustion, number two method means burning. Combustion is burning the fossil fuel. Okay, we call it combustion. The process is called combustion. Okay, burning fossil fuel. If you burn fossil fuel, gas, natural gas, petroleum, crude oil, whatever, you burn fossil fuel, you will return carbon dioxide to the air. So in the exam, they ask you to explain these two processes by which carbon dioxide is returned to the air. Okay, so that's that for that. Now, the two processes of taking away carbon dioxide from the air is by photosynthesis. If you're taking it away, taking it from the air, one is by photosynthesis. We have taken it photosynthesis. This photosynthesis is not only by the plants on land, also by the phytoplankton in the sea. Also by the phytoplankton in the sea. So we say number one is photosynthesis. Number one. And number two method of taking carbon dioxide away from the air is dissolving it in the ocean. Dissolving carbon dioxide in the ocean. So these are the two ways of taking it away from the air. And we've also talked about two ways of releasing it to the air. So these are the things you need to be able to explain in the exam. Okay? Once you know this, then you already know carbon cycle. Once you know this, and you're able to draw the diagram, that's it. You're able to explain the carbon cycle. Now let's go to in details. Let's take in photosynthesis, removing it. We say removing carbon dioxide from the atmosphere. Let's write equation. How is it being removed from the atmosphere? Number one, we say by photosynthesis, right? We say by photosynthesis. We say removing it from the atmosphere, we say by photosynthesis, removing carbon. So I just write CO2, removing CO2 from the air. CO2 from the atmosphere, okay, I can just write air for simplicity. Removing CO2 from the air. Number one is by photosynthesis. Now, this photosynthesis, how do photosynthesis remove carbon dioxide from the air? Like we already explained during the carbon cycle, we said that the carbon dioxide in the air goes into through the stomata of the leaf to enter and go to the spongy layer of the leaf, right? So and then to palisade, where this will react with the water that is absorbed that came through the root air through the xylem vessels, react with the water that entered the leaf also, and then to form glucose, to form food. Okay, so the carbon dioxide in this regard has been taken out. The carbon dioxide in the air has entered the leaf, and this carbon dioxide reacts with water to produce food, to produce glucose, okay, which is the carbohydrate, the basis of the simplest unit of carbohydrate, okay. So this is what we plus oxygen, and in the process also produce oxygen. The plant don't need this one; it gives it out also. So this is one way. This is one way of taking it out. And here, remember we say sunlight, chlorophyll. The chlorophyll has a green pigment that traps the sunlight energy. Okay, this is biology. You know this aspect. You already know. So we say the chlorophyll traps the sunlight. So I just write sun or light. You can just write light here. Trap the sunlight energy, which help this reaction to be able to take place. Without the light energy, this reaction will not be able to take place. So that's number one. Number two, we say by dissolving the air. We've talked about that. Then we've talked about, remember these two processes of adding carbon dioxide to the atmosphere or to the air. We've mentioned the two processes of adding carbon dioxide to the air. And let's begin to look at these two processes. Adding CO2 to the air. Just equation only. Just write equation because I've already described to the air. So I've already described the process just for us to write the equation to the atmosphere. Okay, you can write atmosphere. I'm just using air for simplicity to be able to write faster. So we say during number one process is respiration. Respiration is when the glucose, the food you eat, the glucose that is manufactured by the plant, we react with the air we breathe in, which is called oxygen. We react with the air we breathe in. Actually, respiration and photosynthesis, they are opposite. It's like vice versa. You see, in photosynthesis, it's like we move like this. This is respiration. This photosynthesis, using this reactor to form this product. In respiration, it's like we're going this way. We're going backward. You see glucose plus oxygen will form these two things. Now, you see, in respiration, the air we breathe in, which we call oxygen, react with the food, the glucose. Okay? React with the food to produce what? To produce carbon dioxide. See, carbon dioxide is produced, which we breathe out, which then goes to the air. That's why we say respiration return carbon dioxide to the air. Plus water, plus energy, plus water, plus energy. Energy was part of the process, sunlight energy. But this time around, maybe chemical energy. Energy is also produced. You can call it ATP. But let me just write energy, plus energy. So respiration produces this phenomenon. The energy is what the body uses for development, for growth, for whatever you need the energy for. And then the water also to lubricate the body. But this one is a waste product which has to be breathed out. And then it goes to the air. So respiration returns this one to the air. So that's how respiration returns carbon dioxide. How respiration returns carbon dioxide to the air. In the case of combustion, let's take a methane. Okay, let's write the equation for the second one. Methane gas. Let's say you have methane in your car. Okay, as fuel. Okay, methane gas react with oxygen because anything combustion means burning, means burning. Anything burning means react with oxygen. So methane gas react with oxygen because there is air in the engine. So this fuel is in the engine, air is also in the engine. So they will react, right? Methane gas will react with oxygen. Oxygen is also a gas, right? To produce carbon dioxide in when there's excess oxygen. Because in this case, I'm talking about excess oxygen. Because if there's short supply of oxygen to produce carbon monoxide, which is even more dangerous to produce carbon monoxide. But in this case, let's assume there's excess oxygen, and then this will produce carbon dioxide, okay, CO2, which will be released to the air or to the atmosphere. Okay, you see how combustion releases CO2 to the atmosphere. Produce CO2 should be released to the atmosphere plus water plus energy plus water, H2O plus energy. The energy the engine uses, okay, the energy could be in form of heat or so on and so forth, okay, plus energy. So this is how combustion releases carbon dioxide to the air, to the atmosphere. So you burn fuel like CH4 gas. They're all gas. I'm not into balancing or into anything. I'm just showing you the process. Okay? I'm just showing you the process. So we have methane gas react with oxygen. These are state symbols. These are called state symbols. React with oxygen, which is also a gas. Methane gas react with oxygen, which is also a gas, to produce carbon dioxide, which is also a gas, plus water, which is a liquid, plus water, plus energy. So you can see this is how this one is carbon dioxide is returned to the atmosphere. Okay, so that's that for that. Now let's go to another subheading, what we call some carbon compounds. Let's briefly look at some carbon compounds, and then we call it a day. Okay, say carbon compound. Carbon compounds. We abbreviate the compound, okay? Carbon compounds. Okay. Carbon dioxide is a compound, right? So we say the gas carbon dioxide occurs naturally in the air. We already know this. In fact, that's what we'll be dealing with. It's also a product in three reactions. For example, when the combustion reaction takes place of carbon compound with plenty of air, carbon dioxide will be released. So we don't need to rewrite it. We already have it during combustion. We come here, okay? During combustion, carbon dioxide is produced, right? Carbon dioxide is produced during combustion. Another way is during respiration. During respiration, let's look for the respiration one. So respiration, carbon dioxide is also produced. Now the third one is acid and carbonate. So we can measure them. The three ways in which carbon dioxide is produced in the air. Number one, combustion. Through combustion. Through respiration. Combustion. Three ways in which carbon dioxide is released to the air. One, combustion. Number two, we've written the equation. I don't need to write CH4 plus O2 produces carbon dioxide plus water plus energy. That's for combustion. Okay, the second one, respiration. Respiration, the glucose you eat reacts with oxygen to produce carbon dioxide plus water plus energy also. During respiration, carbon dioxide is released to the atmosphere. Okay. And the third way in which carbon dioxide is released to the atmosphere is by what? The acid reacting with carbonate. Okay, dilute acid. In this case, in laboratory, we studied the acid. Talked about it like in one of our last classes. That the acid we use in laboratory is dilute acid, right? It's not the concentrated acid. Concentrated acid is too corrosive. It's too corrosive to burn our skins. So we dilute it to use in the laboratory. The third one is reacting dilute acid with carbonate. When you react dilute acid with carbonate like H2SO4, I think we did this equation when we did the H2. So dilute acid, if you react it with carbonate, this one we can write the equation since we did write the equation of this one in today's class. Dilute acid, when you react it, when I put plus means react, means they react together when I put plus. Okay, when you react it with carbonate, then you get carbon dioxide. This one, since we did write the equation of this one before, let's write it now. So dilute acid, we can use H2SO4, sulfuric acid, okay, because we just treated sulfuric acid in our previous video. So SO4 plus carbonate, like we can say calcium carbonate. Okay, calcium carbonate, SO4 react with calcium carbonate. Then we will get carbon dioxide. Why? This calcium is higher than hydrogen in the reactivity series. So it will form this salt, calcium sulfate. It will first of all form the salt, calcium sulfate. You form this salt, calcium sulfate. Why? Because in reactivity series, metal can displace any other metal or any other substance that is higher than in the reactivity series. You know, hydrogen may not be a metal, but it behaves like a metal. It's even found with metal in the reactivity series. So this calcium displace this hydrogen and react with this and form calcium sulfate, right? There, that's one. There, this one atom of oxygen here react with this hydrogen to form water. One atom of oxygen here react with this hydrogen to form water. So we have H2O here to form water. There plus. Now what we have left here is CO2, carbon dioxide. See, so you see, when we react dilute acid with carbonate, we always produce carbon dioxide. So this is another way. This reaction we do in the laboratory is also another way of getting carbon dioxide. So these are three ways. This one for this reaction for this one. This reaction for this one. We've written for respiration. The equation for respiration we wrote C6H12, that's the glucose. The food we eat react with oxygen. The food we eat the food is C6H12O6. You master this. You keep it in your memory. C6H12O6. React with oxygen. Oxygen is the air we breathe in. Okay, food and oxygen, they will react together. When they react together in our body, they will produce water, they will produce carbon dioxide, they will produce water, they will produce energy. See, another way of getting carbon dioxide in the air. Okay, water and energy. So we see respiration is a process by which carbon dioxide is released to the atmosphere. Respiration is a process by which carbon dioxide. Reaction of acid with carbonate is a process by which carbon dioxide can also be released to the atmosphere. Okay? And then combustion, that's the burning of gas, any of the gas. We are using methane as an example, methane gas. Burning methane with oxygen, okay? With oxygen, produce carbon dioxide in the atmosphere. Produce carbon dioxide in the atmosphere. So here you get CO2, carbon dioxide, plus water, plus energy. Plus water plus energy. Okay, so these three ways we release carbon dioxide to carbon compound or carbon dioxide to the atmosphere. We release carbon dioxide or carbon compound to that. Now let's take a look at property of carbon dioxide. Briefly, properties. We just talk briefly about the properties of carbon dioxide. Okay, properties of carbon dioxide. We know it, we're familiar with it, it's all around us, but we need to just refresh about the properties of CO2. Okay, properties of CO2. Properties of CO2. Right? It is a colorless gas with no smell. Colorless. So I just simplify it by just writing colorless. So CO2 is a colorless gas, meaning it does not smell. It does not have color and it does not smell. The gas does not have a color. Okay, it's colorless. Number 2 is much higher than air, or you can say it's much heavier than air. Number 2, heavier than air. It's denser than air. Okay, you can say denser than air. Heavier than air. It's heavier than air. Now, number 3 property is that things will not burn in it. It does not support combustion. Okay, so we can simply say it does not support combustion. Or like oxygen, things burn in oxygen. Oxygen support combustion. So we can say not support combustion. Or I think it's more professional. Not support combustion. Meaning things do not burn in carbon dioxide. You don't bring anything and put carbon dioxide and start to burn. No. In fact, it's used for quenching what is burning. You see firefighters, that thing they're spraying is made up, there's carbon dioxide in it. Carbon dioxide is used to stop what is burning. So things do not burn in it. Anything that is burning, spray carbon dioxide to it, it will stop. It will stop burning. Okay? So firefighters, they use carbon dioxide to stop fire incidents. Okay? To stop fire incidents. So because things do not burn in it. It's highly soluble in water, forming carbonic acid. It's very soluble in water. So you can react it with water to form carbonic acid. Highly. But I will just write soluble in water. I mean, it's super soluble in water. It's almost like 100%. Highly soluble in water. And when you react it with water, it will form an acid, which we call carbonic acid. It forms an acid, which we call carbonic acid. Soluble in water. So meaning if I take, for example, if we take CO2 if you take CO2 plus water, if you take CO2 to react with water, you get carbonic acid. You get carbonic acid. Now carbonic acid is H2CO3. H2CO3. Carbonic acid is H2CO3. This is a carbonic acid. So when you react carbon dioxide with water, when you dissolve it, it's very soluble. Soluble in water means it dissolves in water. It dissolves in water to produce carbonic acid, H2CO3. Is that okay? So that's for that. Now let's take a look at the one that looks like carbon dioxide, which is called carbon monoxide. Carbon monoxide. Okay? Because carbon monoxide is gotten when there is no excess of oxygen to burn the fuel. Carbon monoxide. We get carbon monoxide when there is no enough oxygen. There is no excess oxygen to burn the fuel. So instead of produce carbon dioxide, to produce carbon monoxide. Carbon monoxide is a poisonous gas. It's very dangerous, not good. So even in our car, it's very carbon monoxide is a huge pollutant. It pollutes the environment. It destroys so many things. It's very bad. Okay, the symbol is just CO. Carbon monoxide, the symbol is just CO. It's also a compound of carbon. Okay, so now we say carbon monoxide form when carbon compounds burn in little oxygen, right? When carbon compounds burn in little oxygen. If there is no excess oxygen, the carbon dioxide will not be formed. For example, if you take methane like we did before, methane reacts with oxygen. Once the oxygen is not in excess, it's very little, Once the oxygen is very little, it's not in excess, then we get, once the oxygen is very little, it's not in excess, then instead of getting carbon dioxide in the process, we get carbon monoxide. Instead of getting carbon dioxide, we get carbon monoxide. Okay, plus water. So carbon monoxide results when carbon compounds burn in little oxygen. The oxygen is not enough. When the oxygen is not enough, instead of producing carbon dioxide, we produce carbon monoxide. Instead of producing carbon dioxide is still better than carbon monoxide. Carbon monoxide is more poisonous and is more dangerous, and it has its own side effect is way unbearable. So instead of producing carbon dioxide, it starts producing carbon monoxide, which is very fuming. Okay, so when this one burn in oxygen, when this one burns in oxygen that are not enough, little oxygen, then we begin to have carbon monoxide instead of carbon dioxide. So that's that for that. Okay, now let's move on quickly. Let's move on. Now let's go to carbonate. For carbonate, because it also contains carbon, right? Let's quickly talk about carbonate. Then after that, we'll talk about methane and a little bit of other organic compound. Then we call it a bit. Okay. Carbonates are compounds that contains the carbonate ion. Every carbonate, how you know them? They contain this carbonate ion, CO3 2 minus. This one. Any compound that contains carbonate ion is considered a carbonate, like calcium carbonate, sodium carbonate, magnesium carbonate, all the metal carbonates that you know. Okay, so once it contains this ion, CO3 2 negative, then they are called carbonate. An example, like we said, is calcium carbonate, which occur naturally as a limestone. The good example is calcium carbonate. Calcium carbonate is the limestone. We're going to do a section for limestone. Calcium carbonate, okay? Limestone, which we break to make cement and so on and so forth. Calcium carbonate, see, is a carbonate compound. Okay, calcium carbonate, sodium carbonate, zinc carbonate, and so on and so forth. Okay, so this is this one we're going to study. The carbonates are found in the calcium carbonate are found in limestone, chalk, marble, and so on and so forth. Okay, now let's take a look at about a few properties of carbonate. They are insoluble in water. If we talk about properties of carbonate, so I just write properties. They are insoluble. They are not like carbon dioxide. You know, we said carbon dioxide, they dissolve in water to form carbonic acid. They are soluble in water for carbon dioxide. But carbonate, they are insoluble in water. Carbonate are insoluble. We say they are insoluble in water, meaning they do not dissolve in water. When you say insoluble carbonate, you mean they do not dissolve in water. When you say insoluble, they do not dissolve in water. They are insoluble in water, meaning they don't dissolve in water. Carbonate do not dissolve in water. That's their number one. They are insoluble in water, except for sodium, potassium, and ammonium carbonate. Only these three are soluble. Okay, we say carbonate are insoluble in water, except it has exemption. Except sodium, the sodium carbonate. This one is soluble in water, okay? Except the sodium carbonate, which is soluble in water. And then we say except the sodium carbonate, potassium carbonate, and ammonium carbonate. Potassium carbonate, and ammonium carbonate. And ammonium, these three, they are soluble in water. Every other carbonate is not soluble in water. So please, you need to know this exception, this 3. They are in paper 6. Paper 6 of Igcse exam. Okay, when you are doing the practical. Ammonium carbonate. These ones they are ammonium carbonate. These ones they are soluble in water. Every other metal carbonate is insoluble in water. Like calcium carbonate, zinc carbonate, magnesium carbonate, they are all insoluble in water. Only these 3 are soluble in water. Okay, another property of carbonate is that they react with acid to form salt, water, and carbon dioxide. They react with what? Acid. Another property of carbonate is that they react with acid to form salt, water, and carbon dioxide. Okay? Carbonate react with acid. React with acid they react with acid to form what? I think we took one example. See. Was it carbonate? Okay, this one was not carbonate. I think we had one example. Yeah, this is a carbonate. Look at it. Look at this example that we did before. This is an acid reacting with carbonate. So what do you see? They react. This is sulfuric acid reacting with calcium carbonate. They will produce what? The salt, water, and carbon dioxide. So this is one property of carbonate. They can react with acid to produce salt, water, and carbon dioxide. Okay, so that's what I'm referring to here. That's what we are referring to here. They react with acid to produce salt, water, and carbon dioxide. Produce salt, water, and CO2. So carbonate react with acid to produce salt, water, and CO2, carbon dioxide. Is that okay? So that's another property of this. We say they are insoluble except sodium carbonate, potassium carbonate, and ammonium carbonate. The rest of them are soluble. Then we say they react with acid to produce salt, water, and carbon dioxide. Then the third property is that most of them, they break down on heating to oxides and carbon dioxide. Most of them, they break down on heating to oxide and carbon dioxide. Breakdown. They break down on heating. They break down on heating. So we say most of them, they break down on heating to form oxides and carbon dioxide. So we have, let's take this common example, calcium carbonate, which is a limestone. Calcium carbonate, you heat it. Let's heat it. When you heat it, it will decompose, to break down, like decomposition reaction, to form calcium oxide. See, one atom of this react with this, become calcium oxide, then carbon dioxide, plus carbon dioxide, plus carbon dioxide. Okay, so on heating they break down, but this is a reversible reaction. This is a reversible reaction. Okay, decomposition. The forward reaction is endothermic. The backward reaction is exothermic. Okay, the forward reaction, because it's a decomposition. Forward reaction is a decomposition, so it's endo. It's endothermic. This forward reaction is endothermic, and the backward reaction is exothermic. Okay, so that's that for carbonate. Now let's take a look at methane. Okay, which is also we are taking some of these compounds that are what? Carbon compound. We're just looking at a few carbon compounds. Obviously, we're not going to do all. We just take a few of them. There are so many thousands of compounds of carbon. There are thousands of compounds of carbon. Okay, now let's take a look at methane. Now, methane, the chemical formula for methane is CH4, the one we use as our fuel to write the equation for burning, for combustion process. You know, we use the methane to write the equation for combustion process. Now, methane is CH4, right? Now, we say this methane is a compound, and it's found in the gas. The gas deposit in ocean floor and on the land as natural gas. It's usually found as a natural gas. We use natural gas as fuel, right? We use it as fuel to burn so many things. Now to do cooking, to do so many things, okay? It also forms wherever bacteria break down plant material in the absence of oxygen, okay? As example is in the paddy field and swamps and landfill sites. Paddy field like in the rice swamp area. Now, some animals, including cattle, sheep, and goat, and camel, they give out methane as waste product from digestion. Some animals, like the sheep, the goat, the cattle, the camel, they give out methane as waste product from their digestion process. Okay, so that's that for methane. We're not going into in depth. We've written the equation before. If you want us to refer back to it, we can refer back. This one for when carbon monoxide was produced, methane react with insufficient oxygen. When carbon dioxide was produced, methane react with methane also react with oxygen to produce carbon dioxide. So we've looked at methane, it's a natural gas, and so on and so forth. Now the last but not the least, let's just talk about the other organic compounds. Okay, methane is an organic compound. Right? And we say organic compounds all contain carbon. All the organic, in fact, hydrocarbon, you hear the name hydrocarbon, compounds that contain carbon and hydrogen, they are called hydrocarbon. Compounds that contain hydrogen and carbon, they are called hydrocarbon. So almost all the organic compounds they contain carbon. Most contain hydrogen. Not all contain hydrogen, but most of them contain hydrogen. But all of them contain carbon. All the organic compounds they contain carbon. So you can see carbon is widely used as alkanes, alkalines, as alcohol, as carboxylic acids, as even when you go to polymer, all the polymer they contain carbon compounds and carbon elements. So all the organic that you're going to ever talk about, they contain the carbon atom. Most of them contain hydrogen, but not all of them contain hydrogen. So I think with this, we've come to the end of our today's class. Thank you for joining us. Thank you for joining us.